Okay, thanks.
All right. How are we doing so far on that? So I hope on one level it kind of makes sense. Of course, they could have made things different, but it kind of makes sense to have one definition of multiplication that was a number and one definition of multiplication that was a vector. So to start talking about what this vector answer would be, the cross product is the vector that is, well, let's say the cross product of, let's say, u and v. Is the vector that is orthogonal to both. Now that gets a little weird. It's got to be orthogonal to both u and v, and has length u, v, sine theta. So that's a little bit freaky. So when you cross two vectors, you actually end up with a vector that points in a direction somehow orthogonal to both of those. So if my vectors are u and v, where does my cross product vector actually point? Possibly. In what direction will my cross product point? What's the only vector that could be orthogonal to both of these at the same time?
In the middle, z-plane.
And of course, it's got to be orthogonal. So if I put it in the middle, it's not going to be 90-90. Exactly. The only thing that could possibly be orthogonal to both is this guy, or going in, right? And that's kind of course, you know, like, oh, you're cheating, but don't forget you got that extra dimension to think about, right? So that's definitely going to be orthogonal. There's a 90-degree angle here, and there's a 90-degree angle there. Cool. Okay. So I'll tell you what. I think I sensed that I've been talking for way too long. I still want to talk about 11.5, and actually we'll do that when you get done with some of this here. Let me give you this here. See what you think about it.
Stop, I'm messing up.
That's exactly what she I made for all the takes to throw back onto the cell. No, they don't take all anything. Stop, no, that's what us.
Do they just use orthogonal? Do they just use orthogonal because they're doing it in 3D, or is it, did you say parallel too?
Alright, sorry. What's that?
Well, I mean, put orthogonal on the board, but do you just use orthogonal because it's 3D, or is it just because that's how the book says it?
Well, orthogonal is really just another word for perpendicular.
Yeah.
I mean, it really is just another word. You can say perpendicular wherever they say they're orthogonal.
Okay.
Yeah.
All right, guys, so this is what I want you to do. Hopefully the notes I put in there are possibly helpful, because it was pointed out to me, I've got a certain teaching style, and I can't really change that too much, but that's why I try to make handouts to help organize things a little bit. In my mind, I think that's what the book's for, but that's right. I want you to do on that sheet, at the very bottom, 1 A, B, C, D. Yes. 1 A through D. Try those out. And please, if you want to work together, group up, please, your guys, help each other out. Call me over if you need some help.
ABD. Oh, A through D. Yeah, I was like ABD. Okay. So it's A, B, C, and D?
Yeah, A through D.
Okay. Vector of the groove.